It started with a vision: turn one of the most unforgiving environments on Earth into a functioning, fertile, and sustainable landscape. No metaphors, this was a desert. Dry, blistering, bone-deep barren land. And Israel decided to carve a river through it. Not a symbolic one. A real, physical system. Over 12,000 kilometers of engineered canals designed to pull billions of liters of seawater from the Mediterranean, funnel it through the Negev desert, and transform the impossible into the productive.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
The Negev isn't gentle. Summer temperatures often push past 115 degrees Fahrenheit, and the terrain doesn't sit still. It shifts, collapses, and fights back. The desert had to be stabilized before a single drop of water could flow. That first phase was all about groundwork. Engineers used satellite imaging and ground-penetrating radar to assess the constantly moving landscape. They needed to know where to dig, where to avoid, and how to keep machinery from sinking into sand dunes. So they leveled the ground, injected water to stabilize sand, and compacted the terrain until it could carry the weight of massive construction vehicles. Then came the machinery: hundreds of bulldozers, cranes, and excavators sculpting the desert into something usable. But the canals themselves, that's where the project flexed its precision. Every kilometer had to be engineered to perfection. This wasn't about just moving water. It was about managing flow, preventing erosion, and building a system that wouldn't collapse under the weight of its own ambition. These weren't just trenches, they were lined with concrete, reinforced with vegetation, and designed with precise slope angles to ensure gravity could do its job. Supporting structures were integrated everywhere: bridges, spillways, aqueducts, gates, each one critical to managing pressure, directing flow, and preparing for flood events or high-volume surges. The system was built to handle more than daily function. It was built for extremes. Once the skeleton of the project was in place, the focus shifted to the water itself. Channeling seawater into the desert is one thing. Making it usable is another. Desalination became the core process because seawater, in its raw form, is loaded with salt and contaminants. You can't use it to irrigate crops. You can't drink it. You can't even store it in most infrastructure without damaging the system. So Israel deployed an advanced, multi-stage treatment system. The water goes through mechanical filtration, then nanofiltration, then reverse osmosis, and finally chemical balancing. Each stage removes layers of impurities, monitored in real time by digital sensors that track everything: salinity, pressure, flow rate, and contamination levels. This wasn't just about cleaning water. It was about guaranteeing purity, not just for people, but for farms, for livestock, for future growth. And when the treated water finally began flowing through the canals, that's when the desert changed. The first wave of transformation was agricultural. Fields that had been unusable for decades turned green. Farmers returned. Orchards bloomed. Vineyards spread. Vegetables sprouted in places that once cracked and crumbled from dryness. It wasn't symbolic revival, it was economic revival. Communities returned. High-tech farms sprang up. Villages were rebuilt. The desert was no longer an obstacle, it was an opportunity. And this wasn't trial and error. Israel deployed targeted agricultural technologies that made every drop of water count. Drip irrigation systems, which the country pioneered decades earlier, were implemented at scale. These systems deliver water directly to plant roots, drastically reducing waste and boosting yield. In addition, underground aquifer recharge methods were built in, so while water was being used on the surface, excess amounts could seep into deep layers below, restoring natural groundwater reserves. Every part of the project had sustainability in mind. Excavated materials weren't discarded, they were used to fortify embankments. Natural vegetation was reintroduced to stabilize the ground. Control gates and flow systems ensured excess water could be stored, rerouted, or slowed when needed. Nothing was random. Everything was engineered. And throughout all of it, a real-time network of smart sensors ran constantly, monitoring salinity levels, water flow, infrastructure stress, and pressure changes, ready to flag anomalies and optimize performance. This wasn't just a completed project, it became a living system, self-adjusting, self-monitoring, and built to last for decades. But this wasn't just about engineering. It was about national survival. Israel has always had limited natural freshwater resources. The Jordan River, once a lifeline, now struggles under population pressure and regional instability. Groundwater aquifers alone couldn't meet the needs of a growing population and agricultural demand.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
Management, especially desalination and irrigation, is used in dozens of countries. And it all came from proving that even the harshest environments can be reimagined with enough will, planning, and innovation. The broader impact is hard to overstate. As climate change escalates and water scarcity becomes one of the defining global crises of the century, the Negev Desert Project is more than national pride. It's a model for Saudi Arabia, for Egypt, for South Africa, for parts of the American Southwest. It shows what's possible when environmental engineering, sustainable practices, and long-term vision come together. And yes, the cost was enormous, nearly $3 billion, but the return is generational. Agricultural exports are up. Domestic food security is stronger. Local economies are growing. And most importantly, people are staying in the land, building lives where they once would have been forced to leave. That's not just engineering success. That's national transformation. So now the question becomes, what happens if more countries follow this model? What if arid regions around the world start building their own water infrastructure, not just relying on rainfall or depleting groundwater, but actively creating new systems to bring life where nature doesn't? That's where this story shifts from a national victory to a global blueprint. Because the Negev River Project didn't just carve canals through sand, it carved a path forward for water-scarce nations everywhere. If you followed this far, you already know how rare it is to see such a massive, high-risk project actually succeed, let alone reshape an entire region. Let us know what you think. Should more countries invest in artificial rivers and desert transformation? What lessons can the world take from this? Drop your thoughts in the comments. Like this if it gave you a new perspective. Share it with someone who needs to hear it. And subscribe so you don't miss the next deep dive into how human ingenuity is rewriting what's possible. What Israel accomplished in the Negev isn't just about water. It's about redefining limits, about looking at a dead zone on the map and deciding it doesn't have to stay that way. For decades, the Negev was seen as a barrier. Harsh, dry, unstable. You couldn't farm it. You couldn't build on it. The soil didn't hold, the temperatures were brutal, and there wasn't enough water to sustain basic life, let alone agriculture. And yet Israel said, let's build a river. Not a metaphor. A literal, engineered river system cut through the middle of one of the driest places on earth. That kind of thinking isn't just bold, it's radical. Because water is power. And in the Middle East, water scarcity is more than an inconvenience, it's a political flashpoint. Most countries in the region are facing dwindling supplies, growing populations, and climate pressures that are pushing natural resources past the breaking point. So when Israel committed nearly $3 billion to pull seawater from the Mediterranean, pump it across the country, treat it through advanced desalination systems, and send it flowing through newly built canals in the desert, it wasn't just infrastructure. It was strategy. And it wasn't easy. Building over 12,000 kilometers of canals through sand isn't just about digging trenches. It's about reshaping the earth. The Negev isn't a static desert. Its dunes shift. Its ground collapses. Engineers had to fight the terrain before they could even start construction. Ground-penetrating radar, satellite analysis, and core drilling became the first tools deployed, not shovels. They weren't building on land. They were building with the land, transforming it step by step until it could carry the weight of one of the largest water systems in the modern world. The process was surgical. First, level the dunes. Then inject water to stabilize the sand, so it would compact properly. Once the terrain was stable enough, construction began. Dozens of simultaneous teams, heavy machinery, and non-stop work through desert heat. They poured concrete, planted stabilizing vegetation, carved precise slopes into the ground to make sure water wouldn't stagnate or overflow. And then came the real challenge, the water itself. Seawater is abundant, sure, but it's unusable in its raw form. It's filled with salt, bacteria, and microscopic debris. Running it through canals is one thing. Using it to irrigate crops or fill drinking taps is something else entirely. That meant building desalination plants capable of stripping seawater down to its purest form. And not just once. Israel's process involves multiple stages. Mechanical filtration to catch the large debris, nanofiltration to handle microscopic particles, reverse osmosis to eliminate salinity, and chemical balancing to make the water safe for long-term use. That's not basic filtration. That's medical-grade purification done at scale, monitored in real time, and constantly adjusted based on conditions. Sensors track everything: salinity, flow rate, chemical levels, pressure, integrity. If something shifts even slightly, the system responds automatically. The goal wasn't just to make water usable, it was to make it sustainable. Because this wasn't about a short-term fix. It was about long-term viability. Israel didn't just want to survive in the Negev, they wanted to thrive. And that required designing every component with future conditions in mind. What happens in 10 years? In 20? What happens if climate patterns worsen? Or if demand spikes? Those questions shaped every decision, from the depth of the aquifers to the types of crops that could be supported. The results speak for themselves. Formerly barren fields now produce fresh vegetables, grapes, pomegranates, dates. Farmers who left generations ago are returning to cultivate land that was once uninhabitable. Villages that had all but emptied out are rebuilding. Schools, markets, and homes are thriving around a water source that simply didn't exist 20 years ago. And the water use isn't wasteful, it's some of the most efficient on the planet. Thanks to Israel's innovations in drip irrigation, crops receive water directly at the roots, with minimal evaporation or runoff. This is agriculture engineered for scarcity, maximum yield with minimum waste. Every drop counts, and every system is designed to ensure it gets used exactly where it's needed. It doesn't stop at agriculture. The artificial river is also recharging underground aquifers, ensuring the long-term stability of natural water tables that once teetered on collapse. That's a layer of environmental stewardship baked into the system from the start. It's not just about extraction, it's about balance. The project gives back to the land even as it takes from it, creating a cycle that protects the ecosystem and the infrastructure at the same time. And this transformation isn't just physical, it's economic. Agricultural exports have soared. Israel, once dependent on food imports and vulnerable to drought, is now a leader in desert farming. High-tech greenhouses, water-efficient farms, and climate-resilient crops are bringing jobs, investment, and innovation into regions that were once financial dead zones. And the success of the Negev project has become a soft power asset. Countries from Africa to Asia to Latin America are now studying Israel's model, trying to replicate its precision, sustainability, and adaptability in their own drylands. Because here's the truth, the world is running out of water. Climate change isn't theoretical anymore. Entire regions are drying up. Groundwater is being depleted faster than it can be replenished. And for many countries, the question isn't if they'll face water shortages, it's when. Israel's project proves that the answer doesn't have to be panic or collapse. It can be engineering. It can be strategy. It can be long-term planning backed by real investment and real science. And it shows that adaptation isn't a fantasy, it's a necessity. Because what's the alternative? Wait for rain. Drill deeper until the aquifers run dry. Hope desalination becomes cheaper someday. Or build the future yourself just like Israel did. The Negev Canal system is a masterclass in what happens when necessity meets capability, when a country doesn't just respond to crisis, but redefines the rules of the game entirely. It's not just about water. It's about control, about reclaiming power over the environment instead of surrendering to it. This is what happens when technology, policy, and vision align. When a nation decides that it won't be held hostage by geography. When it chooses resilience over resignation. Israel didn't wait for the perfect conditions. It built them. What Israel did with the Negev wasn't just about surviving a harsh climate, it was about refusing to be defined by it. Turning a desert into a functioning ecosystem isn't just a technical win, it's a national statement. Because the truth is, deserts don't forgive mistakes. They don't offer second chances. You either adapt with precision and intention, or you don't adapt at all. Israel made a choice. And that choice has permanently rewritten what's considered possible in environmental engineering. Now, when you talk about modern infrastructure, you're usually talking about roads, bridges, maybe a dam or two. But building a fully functional, artificial river network across 12,000 kilometers of unstable desert terrain is in a completely different category. That's not just construction. That's architectural defiance. And yet, what's most impressive is that it works. Not just in theory or on blueprints, but on the ground, every single day. Water now flows through a place that used to be defined by its absence. Not trickles, not symbolic irrigation, actual rivers. Canals wide enough to transport billions of liters of water annually, lined with concrete, protected by vegetation, controlled by digital sensors, and monitored constantly. This is a system that breathes with the land. But it's not just about having water, it's about managing it. Israel didn't just flood the desert. They built gates, aqueducts, and spillways. They engineered precise gradients so water would flow naturally, without pumps wasting energy. Every part of the system has been built for long-term use. Not just to work today, but to still be working 20, 30, even 50 years from now. That foresight is what sets this project apart. Most water infrastructure is reactive, built in response to drought or shortage. Israel's system is proactive. It was designed before the crisis hit full scale. And that's why it hasn't just solved problems, it's prevented them. The ripple effect is undeniable. With water now abundant in the Negev, entire communities have re-emerged. What used to be inhospitable terrain is now dotted with greenhouses, orchards, and functioning villages. That's not just development, it's renewal. People came back, they rebuilt, they planted, and for the first time in generations, they stayed. The Negev is now home to cutting-edge agri-tech startups, desert farming research centers, and export-driven agriculture. It's not just a place where survival is possible, it's where innovation is flourishing. And that momentum is turning Israel into a global example of climate adaptation that actually works. Other countries are watching, because the desertification problem isn't going away. From sub-Saharan Africa to parts of South Asia and the American Southwest, arid regions are expanding. Rainfall is becoming less predictable, aquifers are drying up, and governments are scrambling for solutions. The Negev model offers one full-spectrum intervention. You don't wait for nature to cooperate, you use science and engineering to create new conditions. You combine infrastructure, desalination, irrigation, renewable energy, and ecological design into a single, unified system. But here's the key, it takes vision. This wasn't done in a single year. It took 15 years of relentless work, billions in funding, and coordination across every level of government and industry. And that's the real lesson. These projects don't succeed because they're flashy, they succeed because they're built to last. Israel didn't aim for a miracle. They aimed for a system, and they built it. Thanks so much for watching. If you made it all the way to the end, you're officially part of the small percentage of people who don't just click away, and that means a lot. Before you go, I'd love to hear from you. Drop a comment below and tell me your thoughts, your ideas, or even what you'd like to see next. I read every single one of them, and your feedback genuinely shapes the direction of this channel. If you enjoyed the video, tap that like button, it tells YouTube this content is worth sharing. And if you haven't already, hit subscribe and turn on notifications so you don't miss the next upload. We've got more exciting videos coming, and trust me, you'll want to be here for them. This channel is just getting started, and your support helps it grow faster than you realize. Thank you again for spending a part of your day here with me. Stay curious, stay motivated, and as always, take care of yourself. Until next time, I'll see you in the next video.